Greetings to you, all my dear students. In this video, we are going to see the traveling salesman problem. So, this is the main important topic in data structures and algorithm paper. So, let us discuss about this traveling salesman problem. What is traveling salesman problem? It is a well-known combinatorial optimization problem where a salesman must visit n cities exactly once and return to the starting city while minimizing the total travel distance. So in a graph, there will be many nodes. That nodes represent cities. So here the problem to this traveling salesman is to visit all n cities exactly only once, and he has to return to the starting city while minimizing the total travel distance or total cost. See, either distance or cost. So he has to visit all the cities. So here let us consider D is equal to D comma E. D is nothing but the vertex, E, edge. So set of vertices and set of edges. So it be a directed graph with edge cost Cij or the distance, okay, Cij. Cij is defined such that Cij is greater than 0 for all I and j, and Cij is equal to infinity if there is no edge between I and j. Okay, if there is no edge between I and j, then Cij will be infinity. If there is an edge between I and j, that Cij must be greater than 0. And let mod of b is equal to n. So here n. So the vertices, the number of vertices is equal to n. And assume n is greater than 1. Of course, n should be greater than 1. Then only this problem exists. If there are no cities, no problem. If there are n cities, there is a problem. So next, a tour of D is a directed cycle that includes every vertex in D. The tour of D is a directed cycle. Why it is directed cycle? The traveling salesman should start from a city, and after visiting all the cities, he has to return to the city where he has started his tour. So it is a directed cycle that includes every vertex in D. So the cost of a tour is the sum of the cost of the edges on the tour. The cost of tour is the sum of the cost of the edges on the tour. And the traveling salesman problem is to find a tour of minimum cost. So every tour consists of an edge, 1, k. For some k belongs to v minus 1. So k here means set of vertices. So he starts from 1, k. K is nothing but vertices minus 1. Except the vertex 1, he has to travel all the other vertices. So k here is the set of vertices. Then, and the path from vertex k to vertex 1. So at last, okay, so after consider there are 4 cities. So 1 to 2, 2 to 3, 3 to 4, then 4 to 1. Next point, the path from vertex k to vertex 1 goes through each vertex in v minus 1, k. V minus 1, k exactly once. And it is easy to see that if the tour is optimal, then the path from k to 1 must be a shortest k to 1 path going through all vertices in v minus 1, k. Hence, the principle of optimality holds. Every time we are selecting the optimal route. So, the principle of optimality which will be holds. Then let g of I, s be the length of the shortest path starting at vertex I, going through all vertices in S and terminating at vertex 1. So G of I, this notation is used to find the length of the shortest path starting at vertex I. Okay. So for example, G of 1 comma B minus 1, the node 1 or the city 1, and the next component is the remaining cities 2, 3, 4. Okay, the set is the length of optimal salesperson tour. So from the principle of optimality, it follows that G of 1 comma V minus 1 is equal to minimum 2 less than or equal to K less than or equal to N, C of 1K plus G of K comma V minus 1 comma K. It's nothing but when you do the problem, you will understand that you have to start from the vertex 1 or the city 1. Then you have to find the remaining cost, okay, for the tour. So this is the formula. So generalizing, we are getting G of I comma S is equal to the minimum of J belongs to S, C I comma J plus G of J comma S minus J, the remaining one. When we do the problem, we will understand. Okay. So it may be solved by using this. We know for all choices K, the G values may be obtained by using the 5.20. That is the equation number. So clearly G of I comma pi is equal to C of I comma 1, where 1 less than or equal to I less than or equal to N for all I. Hence we may use this 5.20 to obtain G of I comma S for all S of size 1. Size 1 means consider only one vertex, the first vertex. Okay, so for that the cost is D of I comma pi, which is equal to CI1. Okay, CI1. Then we can obtain G of I comma S for S. Okay, the length of S is equal to 2. We have to consider the edges from the starting vertex to the next vertex. Then we have to consider with length of S is equal to 3, length of S is equal to 4, so on. So S for which is needed such that I is not equal to 1, then 1 does not belong to S and I does not belong to S. Okay. So consider this problem. While we solving this problem, you will understand the algorithm. So here this is the graph. This graph is a directed graph, and we have the connectivity from 1 to 2 and also 2 to 1, 2 to 3 and also from 3 to 2. So this is converted into a directed graph 1 to 2, 2 to 3, 3 to 4, 4 to 1, and it has all. So here the matrix is given for all 4 nodes 1, 2, 3, 4. There are 4 cities 1, 2, 3, 4. Here it is 0, 1 to 1, 0, 2 to 2, 0, 3 to 3, 0, 4 to 4, 0, 1 to 2, 10, 1 to 3, 15. Then 1 to 4, 1 to 4, 20. So in that way you have to fill all the entries of this graph. So here we are going to solve. So first let us consider this city 1. From city 1 you have, listen, you have connect edge to 2, edge to 3 and edge to 4. So 1, 2, 2, there is an edge. 1, 2, 3, then 1 to 4. And from 2 to 1, 2 to 1. See, 2 to 1 it is there. But we have already visited that node 1. So you need not to have one more 2 to 1. Instead 2 to 3, 2 to 4. Then from 3, 3 to 1, 3 to 2, 3 to 4. But 3 to 1, already we have visited this one, so no need to have that branch. So from 3 to 2, then 3 to 4. And again for 4, okay, 4 to 1, we have visited 1. So the cost already we have 8. And 4 to 2, 4 to 3. Okay. So then from 3 to, you look at this. So we have visited 1, 2, 3. The remaining 4. And consider this part 1, 4, 3. The remaining 2 and 1. And consider this 1, 3, 4. Remaining 2 and 1. So from 3 you have 1. Already you have visited 1. So you need not to have that branch. 3 to 2. Okay, already you have visited because the previous 3 to 2 already visited 2, 2 to 3. So 3 to 4. So 3 to 4. So 4 to 3. 2 to 4. 4 to 2. 4 to 3. 3 to 2. So here, you just consider 1, 2, 3. Every part are unique. 1, 2, 3, 4. 1, 2, 4, 3. 1, 3, 2, 4. So all parts are unique. So next from 4. So traveling salesman problem enanga here is you have to go back to this one. Go back to this one. 1, 2, 3, 4. After visiting the city 4, he has to go to 1. So here 1, 3 to 1, 4 to 1, 2 to 1, 3 to 1, 2 to 1. Okay, so now how we are going to solve this? Okay, so now you write the cost 4 to 1. The cost 4 to 1 is 4 to 1, 8. Okay, the initially that CIJ, okay, 4 to 1, 8, 3 to 1, 6, 4 to 1, 8, 2 to 1, 5, 3 to 1, 6, 2 to 1, 2 to 1, 5. Okay, then 3, okay, now you have to find the cost from 3 to 4 and 4 to 1. See, listen, 3 to 4 and 4 to 1. For that, you have to consider 3 to 4. How much? 3 to 4? 12. 3 to 4 is 12. So already 4 to 1 is 8. So 12 plus 8, 20. Okay, understand? And here 4 to 3. 4 to 3? 4 to 3 is 9. So 9 plus 6 is 15. Okay, similarly 2 to 4, 10. 10 plus 8, 18. 4 to 2. 4 to 2 என்னங்க 8. So 8 plus 5, 13. Okay. And 3 to 2, 3 to 2, 13. 13 plus 5, 18. Okay, and go back. Go back to this 2. Okay, we have visited from 3 to 4, 4 to 1, and 2 to 3. So 2 to 3 to 4 to 1. You have to calculate the cost from the city 2 to 3 to 4 to 1. So what is the cost of 2 to 3? 2 to 3 is 9. So 9 plus 20, 29. Right? 29. Next, 2 to 4. 2 to 4 is 10. So 10 plus 15, 25. Here there exist two possible paths. One is from 2, 3, 4, 1. And the another one is 2, 4, 3, 1. So you have to explore the two possibilities. 9 plus 20, 29. 10 plus 15, 25. Then similarly from 3 to 2. 3 to 2, 13. Okay, 3 to 2, 13. So 13 plus 18, 31. Okay, so 12 plus 13, 25. Here 4 to 2. 4 to 2, how much it is? 8. 8 plus 15, 23. 4 to 3, 9. 9 plus 18, 27. Right? So next, here you have to choose the minimum. Okay, minimal cost. Here it is 29, 25. The minimum is 25. 25. So we are choosing 1, 2, 4, 3, 1. And here we are choosing 25 because this 31, 25, 25 is lesser than 31. So 1, 3, 4, 2, 1. So next, out of this 23 and 27, 23 is less. 23 is this one. 1, that is 4, 2, 3, 1. Okay, so now we have 3 options. This is 25, 25, 23. Okay, so now we have to calculate the cost from 1 to this. From 1 to this. We have selected this 25. So 1, okay, to this part. 25. Take this 25. So 1 to 2. How much cost is 1 to 2? This one. Okay, 10. So 10 plus 25, 35. And again 1 to 3, 15. 50 plus 25, 40. Then 1 to 4, 20. 20 plus 23, 43. So out of which one is, out of this, which one is minimal? So this is minimum. Which one? 35. 35. So 10, 1 to 2, 10. Okay, this 1, 2, 4, 3, 1. 1, 2, 4, 3, 1. So this is the part. Okay, the part. Okay, so this is a directed cycle. One visiting the traveling salesman will start his travel from the city 1, go to city 2, and go to city 4, 4 to 3, again coming back to 1. Okay, so this is the solution. So how to solve by using this algorithm or formula? So we have to apply like this. We are now applying. So here, okay, so the same thing. Let us have this. So consider the case where the length of S, okay, the length of S is equal to 0. 0. He is there in G of 2 comma pi. Okay, 2 comma pi is equal to C21. 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 The cost is 5. Okay. And C31. Cost is 6. And C41. Cost is 8. Okay, you have to write 5, 6, 8 for the case the length of S is equal to 0. Then you have to apply for length of S is equal to 1, where we have from 2, okay, from 2 comma 3, then 2 comma 4, then 3 comma 2, 3 comma 4, 4 comma 2, 4 comma 3. So you have to find the cost. So where it is, the formula is C23, 2, 3, okay, which is 9, plus G of 3 comma pi. 3 comma pi is 3 comma pi. Okay, G of 3 comma pi is 6. 6 is equal to 15. G of 2 comma 4 means, which is nothing but C24 plus G of 4 comma pi, which is 18. Okay, so here you have calculated all the G of 2 comma 3, all the possibilities. G of 2 comma 3, 3 comma 4, 2 comma 3, 2 comma 4, 3 comma 2, okay, etc. So now we have to apply for the length 2, okay, visiting the cities, 2 cities. So G of 2 comma 3 comma 4. Paranga G of 2, 3, 4. G of 2, 3, 4. Min of 2, 3 plus G of 3, 4, C 2, 4, 2, 2, 2, 3, 2, 4. Here 3, 2, 3, 4. Here 4, 2, 4, 3. Okay, we have to find all the possibilities where in which you have got 25, 25, 23, 25, 25, 23. So you get this minimum cost. 29, 25, here 29, 25, here 31, 25, 23, 20. After that, finally, we compute the equation 2 for length of S is equal to 3. Okay, length 1, 1, 2, 3, 4. So, from 1 to and G of 2, 3, 4 plus C of 1, 3, G of 3, 2, 4, C of 1, 4, 4 to 1, 3. So, when you write here 1, 2, you have to avoid 1 here. When you write 1, 3, you should avoid 1 here. Here also 1. So, this is the formula. You have to work on this formula to find out this thing. So, next, so an optimal tour of the graph of the given length has given 2 has length 35. How 35? Among this 35, 40, 43, the minimum is 35. A tour of this length may be constructed. We retain with each G I of S the value of J that minimize the right hand of 520. Wherever you have different paths, you should choose the path with minimal cost. So let J of I, S be this value, then J of 1, starting from 1, 2, 3, 4, whether 1, 2 or 1, 3 or 1, 4. Which one is minimum? That you have to choose. That the 2 starts from 1 and goes to 2. The remaining 2 may be obtained from G of 2, 3, 4. So out of this you have chosen this 2. Then 2, 3, 4 you have to choose. Which one? 4. So from the next stage is 2 to 4. 1 to 2, 2 to 4, then 4, 3. So which is 3. So 1 to 2 to 4 to 3 to 1. So the optimal tour is 1 to 2 to 4 to 3 to 1. So that's it, students. You can understand this, say, a traveling salesman problem by listening this video. If you have any doubts, you can contact me or else you come and ask your doubts. Thank you.